I'm Phil Lichtenberger, W2LIE, and welcome to Scanner School Session 5. Today we're talking about AM, FM, sideband, wideband, and narrowband FM. Coming up now on Scanner School.
Welcome to the Scanner School, a podcast dedicated to the scanner radio hobby. Class is about to begin. Here is your host, Phil Lichtenberger.
So welcome to our 5th session of Scanner School. I'm Phil Lichtenberger, W2LE, and today we're going to talk about amplitude modulation, sideband, both upper and lower, frequency modulation, including wideband and narrowband FM, plus what that means for you and your scanners. So as always, the notes for this session can be found on our website by adding the session number to the end of the URL. So this is session number 5, so if you visit scannerschool.com/session 5, you'll be taken to the show notes for this podcast session. And we also have a free cheat sheet you can download that will outline some of the terms that we discuss on the podcast. So I know it's kind of difficult to kind of visualize what I'm talking about, and that's really what the point of the bonus material is for. If you go to the website, again, scannerschool.com/session 5, you'll be able to download a visual guide to kind of help you understand what I'm talking about. Because honestly, I know a lot of what I talked about in the last couple of episodes have been pretty dry content. And I'm trying something a little bit new, if you can't tell already, with this podcast. So I'm trying to be a little bit more not so scripted and discuss a lot of this off the top of my head. So hopefully this session isn't as dry as sessions 2, 3, and 4. But the other good news is that this is really wrapping up the core of what you need to know when it comes to the scanner radio hobby. We're done after this session with all of the dry stuff. Okay, we'll get into more of the fun stuff coming up on future podcasts. So that includes trunking and how trunking works and the different forms of trunking. I know a lot of you people have submitted your questions about that. Also on P25 and antennas and preamps and amplifiers and all that other good stuff. Really, we won't talk about amplifiers on Scanner School. It's more the transmission side of the house. But we'll get into some of the more tangible stuff coming up from this point forward. Okay, so again, this is the end of the dry stuff. So if you've listened to 2, 3, and 4, and now you're sitting here at 5 saying, I don't think I could take this anymore, please, just a couple more minutes, and we'll get through some of the remainder of the dry stuff, all right? So if you can't tell, I'm doing a lot of this stuff off the top of my head now. I have my bullet points out here that I want to discuss, and before it was scripted, and we're not going to be scripted from this point forward, okay? So hopefully this brings a little bit more energy into the podcast. I also have some sound bites I'm going to pepper in here, so hopefully that keeps you guys awake. Again, I apologize for the previous sessions being a little bit dry when it comes to content. So let's get right into what we're going to talk about today so I can get you guys moving and awake. Amplitude modulation, abbreviated by AM, Alpha Mike. It's got to be one of the earliest forms of methods of transmission done over radio, done so in the early turn of the 20th century, the early 1900s. Now, AM consists of a carrier wave, which is 2/3 of the total power required to transmit on that frequency. And then it also consists of a bearing modulation waveform, which is the actual voice transmission, I guess you can think about it. And that's 1/3 of the total power. All right, so you have 2/3 of your energy wasted just on the actual carrier wave, and only 1/3 of that power is the medium or your voice. All right. Now, AM is also made up of 2 sidebands, an upper and a lower, and they are an exact mirror of each other. So let's make a picture of what AM looks like in our heads. And the easiest way I can think of to do so is we've all been on a body of water or a lake, whatever you want to call it, and you have an image out on the horizon, or you can even say the body of water is even a puddle, right? And if you're looking out over this lake and you see the mountains ahead of you, you also see an exact mirrored copy of those mountains reflected back to you in the water. right? So you have, let's just say above the horizon, the mirrors would be the upper sideband, and the reflected image of that would be your lower sideband. And the flat horizon, let's just say that's the carrier wave. In your mind, hopefully now you have a picture of what an AM carrier or an AM signal looks like, okay? So the actual top and bottom, right? The peak of the mountaintop and the peak of the reflected is the whole envelope. And then where the mountaintop goes down, it meets up with the water again. And then it repeats and goes up and down, up and down, up and down. That's what you're looking at on an AM carrier if you actually saw it on an oscilloscope. And again, I'll have a couple of pictures in the session note downloads that you can really take a look at. Sessions, scannerschool.com/session5. Okay. So what are some of the pros of AM? Well, multiple stations can be heard at the same time if they were keying up at the same time. All right, we've all been into a restaurant where you have multiple tables there and multiple people are having conversations, and it sounds like a lot of noise, but you can really pinpoint one table's conversation. You can talk to the people who are at your own table, or you can listen in on other conversations around you. I mean, we've all done it, right? That's kind of like what AM is like. All right, you can kind of hear everybody in the room together, or you can single out what you want to listen to. All right. AM being one of the very simplest forms of radio communications, it is very simple to build a circuit to listen to AM. So because it's a very simple circuit, it's very cheap to manufacture. Okay. The other nice thing about AM signals is that it reflects back to Earth in the ionosphere layer. Right, the Earth and has different layers of the ionosphere, and what happens is, like a mirror, the frequency wave will go up into the sky, will hit the ionosphere, and bounce back down to Earth. This allows the signals on AM to propagate several thousands of miles away. If anybody's used a shortwave receiver, you know that firsthand. You can listen to stations. Sometimes you need to actually go on Google what you're listening to, but you can listen to stuff halfway around the globe using just simple AM, okay? We may even be able to experience that at home. I don't know if some of you have experience by listening to AM, that maybe you'll hear a station that's clear across your own country. I know there's been mornings where I'll hear southern states coming in over my own local AM receive frequencies. Okay, so that's a really interesting way of how AM works. All right, let's talk about some of the cons of AM and why it's just not efficient. Remember, we use 2/3 of our total power output just to key up and get a waveform out there. All right, only 1/3 of the signal is actually used for your voice medium. So it's a very inefficient way of communicating. The other thing that's a problem with AM is that a lot of man-made electronics can interfere with the AM carrier, or the AM signal. So if you had a motor, or sometimes even, the wall warts you plug into the wall, that kind of stuff can generate noise that will interfere with AM reception. Another electromagnetic noise that can interfere with it is lightning. And I don't know how many of you have ever tuned your AM receiver in the car to an empty AM station, and you can hear the crackling coming across the AM receiver. That's the noise of lightning coming across your radio. Okay. So who uses AM? Well, here in the States, CB is AM. We have AM broadcasts, which we all know, and it's great for like talk radio, sports radio, even news. That kind of stuff is great on AM because it's just it works better. It sounds okay, and it can get through some of the noise that's out there. All right. So let's take a quick break from me explaining things to you, and let's do a little soundbite here. Again, something different for the podcast. I want you to take a listen for AM. This is my local airport tower. That's just a couple minutes from my house. And you'll hear what AM sounds like on your receiver, listening to air traffic control.
Is estimated 14010, and runway 19 is available. You can taxi via Bravo and hold short of 32 on Bravo.
All right, so that was an example of AM transmission. So remember how before we have the top half and the lower half of AM? What if you can just isolate that? That's sideband. What sideband does is it removes the carrier wave, and that's where you lost 2/3 of your power. And now you can concentrate all of your energy on the sideband. And again, when we do upper and lower sideband, we're also removing the other sideband. So if you're on lower sideband, you remove the carrier and the upper sideband. If you're on upper sideband, you remove the carrier and the lower sideband of things. Now, sideband is normally abbreviated, it is a generic term as SSB, or Sierra Sierra Bravo. If you're talking lower sideband, it's Lima Sierra Bravo, LSB. Upper sideband is USB, or Uniform Sierra Bravo. Okay? So it's a much more efficient way of transmitting, okay, and getting signal out there. Again, just like AM, you could have multiple stations on the same time being heard. Because it's more efficient in power, it can go even further than AM. All right, it's much more efficient in the bandwidth that it uses because it's only that lower portion. You're not transmitting the mirror image, so it's a lot more narrower than standard AM. Okay, so who uses sideband? Well, us amateur radio operators, we're very familiar with sideband because we use it on HF voice, lower or upper sideband, depending where you are in the band. Sideband is also used by HF utility communications and military and that kind of stuff. So anybody who's used an HF receiver, shortwave receiver, to monitor, Coast Guard or that kind of stuff, typically is used on upper sideband. All right. So let's take a quick listen here. It was a contest here in the States last night, so I tuned up my HF receiver and went down to the 40-meter band, and I have an audio bite here for you just to take a listen to so you can hear what lower sideband sounds like.
Alpha, Alpha, 9 Alpha, contest. 54 Alpha, Quebec Lima. 54 Yankee Kilo, Tom, Wisconsin.
Dan, Delta Alpha, November, North Carolina.
Thanks, Dan. Good luck, Alpha, Alpha, 9 Alpha.
Alrighty, so that wraps up AM and sideband communications. So now we're going to take a look at FM, which is what most of us are familiar with. Okay, so FM is abbreviated by FM is frequency modulation. It's abbreviated FM, and it's Fox Mike. Okay, so the RF carrier frequency is varied based on the modulation. Whereas AM, you had the uppers and the lowers, the mirror image, and inside of that was the amplitude modulation. With FM, the frequency is like an accordion. It goes in and out based on the modulation signal. So the typical carrier bandwidth of standard FM is 20 kilohertz wide, meaning it uses this much RF spectrum when you transmit. So I'm going to use this as an example. I'm sure a lot of people are going to start yelling at me for it, but I want to be able to make sure you understand when we talk about wideband and narrowband and even the new narrowband, how much that equates to. So let's all talk in terms that we're familiar with here, okay? So for you, you guys that use metric, let's talk centimeters. And for all of us in the rest, the United States, that uses the imperial method, we're going to talk in inches. So in your mind, let's think about 25 inches or 25 centimeters. That would be something that you can picture in your mind, and that's how wide the bandwidth is on a standard FM transmission. All right, 25 inches to 25 centimeters. So the pros of FM is that information changes in frequency with your accordion, rather than amplitude or the height. Okay. It also covers better the frequencies that you can hear. So it's naturally, it just sounds better to us. Some of the cons of FM is that it's absorbed by the ionosphere, whereas AM would bounce back to Earth. FM just goes out, straight line out into space, doesn't reflect back. Now again, vacuum here, right? We're not talking about skip, ducking, all that other fun stuff that we talk about when it comes to FM and all that good stuff, right? We're just talking about straight transmissions, no magic, all right? No magic here. So who uses FM? Commercial broadcast radio, two-way communications use radio. Before going digital, your TV was FM, all right? So we have our FM carrier, 25 kilohertz wide, all right? In our minds, we're thinking 25 centimeters, 25 inches. Wideband FM is our commercial stereo reception. Wideband FM is abbreviated by WFM. All right, Whiskey Foxtrot Mike. And it's got better sound to us because there's enough width in that frequency range or that bandwidth to have an independent left and right channel for stereo. Now there's also some extra room in the bandwidth for extra data, right? So you can have I guess what they call the SRS, which is the text that you see. It comes across the stereos now, new modern stereos. With HD radio, you can have room in there for an HD channel. So there's extra room in there for some extra bells and whistles, right? And the typical frequency width of wideband FM, and why it's called wideband, it's 200 kilohertz wide. So standard FM, 25 kilohertz, 25 inches, 25 centimeters. Wideband FM is 200 centimeters or inches wide. That's wide, right? So let's go back and think about what we talked about in session 3 of Scanner School, which was PL, DPL, and NAC was the topic. And how we use PL and DPL to kind of filter out everything we didn't want to listen to because you had too many people using the same frequency. Well, on FM, how do you get more people? As another way to do it is you now shrink the bandwidth that each carrier uses. So narrow FM has a typical bandwidth of half of standard FM. So now your typical bandwidth is 12.5 kilohertz. All right. So an example of this would be your typical commercial two-way traffic now, public safety and all that stuff would be 12.5 kilohertz. All right, let's stop and think about this a different way. We used in session 2, your FM receiver was on 102.3 megahertz. All right, that's the center channel of your FM carrier. If you move the dial up or down by 0.1, right, you're going to still hear what you want to listen to, but it's going to sound all staticky, right, because you've moved the center frequency down. But the reason why you still hear it is because from 102.2 to 102.4 is the actual width of the wideband FM channel, all right? Which is also why, too, when you're listening on your scanner and you're kind of off frequency a bit, you could still hear the transmission. So if we take, for example, on our scanners, 162.5, just as an example, here in the States, that's the NOAA Weather Radio channel. It actually will broadcast down from 162.4375 up to 162.5625. Now 162.55, which is the next channel up, overlaps it slightly by 162.4875 to 162.6125. So that's kind of inefficient in a way because you can't really cram as many people onto a single frequency if they're too close to each other. All right? So now what do? We go into the new narrowband FM, which is 0.625 or half of the traditional narrowband FM. All right? So now you've compressed the width of the carrier that's used for every transmission. All right, so now you've effectively doubled the amount of licenses and users on a channel. So scratch your head here for a second. Think about, well, how do I set up my scanner now? Do I do wide FM or narrow FM? Really, what I think you should do is go with NFM. All right, that's really where you want to be, unless you listen to something on the VHF low side, 46 megahertz, at least here in the States. But general rule of thumb, these days, you go narrow FM. So let's take 1 second here. I got one more audio sample for you. I want to take a listen to a narrowband FM transmission. This is a 12.5 kilohertz wide transmission. This is a fire department that's pretty close to me, and I just want you to hear what it sounds like.
6903. Broken water pipe. Water and utilities to the house have been shut off. All units on the 13 and 18th Division 2. 236903. Signal 18 Station 2.
All right, and that is narrow FM. So with that, I think we survived. We've talked about AM, FM, and we're still here. So let's get on to today's sponsor, East Coast Pagers. So East Coast Pagers is a Unication, Apollo, and Swiss phone dealer serving the U.S. market. From one-way numeric and alphanumeric pagers to voice NP25 pagers, they have your department covered. Check out eastcoastpagers.com for Unication G1, G4, and G5 products and accessories. All Unication G1 pagers ship with a spare set of batteries and a spare belt clip. All G4 and G5 orders will ship with a spare belt clip. Complimentary programming of your department's dispatch and firegrounds are included. Please contact eastcoastpagers.com for a custom quote for your department. All right, don't go to the website and say that's the best price. Contact East Coast Pagers for a custom quote. That's eastcoastpagers.com. So we have some feedback that came into our inbox this week, which you can submit your feedback using the contact form at scannerschool.com. And don't forget, you can leave me a voicemail at using the speak pipe icon on the scannerschool.com website or in each session note. But we got a new method that you can leave feedback this week too. You can leave me a voicemail at 516-308-2885. That's a US-based number. Again, 516-308-2885, and we'll play your voicemail back on a future podcast. So we have our first one back that came in from Scott. It says, Phil, have you heard the rumors about any new Uniden scanner? As you've probably heard, Universal Radio accidentally posted a picture and description of a Uniden SDS 100. Is this a real thing? There's a Google cache of the site, but I'm still skeptical. Thoughts? And he also writes, great podcast on sessions on simplex, duplex, and repeaters this week. Scott, thanks for the feedback on the podcast. And I have seen Twitter and Facebook and Radio Reference light up over this one, as they typically do when Uniden leaks out a new scanner. So one of the easiest things to do is if you take a look at the FCC website and see if you can find something on there, something's been approved or not. That's usually a really good indication that something is in the pike. Now, is this vaporware? Is this something new? Is this a rumor? I don't know. I mean, we're still a little far from April Fool's Day, so maybe thinking this could be a new scanner coming out by Uniden. And again, we'll talk more about it when things are more definite, and I am planning on having a full review of the scanner if it ever sees the light of day. So as of right now, it just leaked out this week. I'll be watching, as I'm sure most of you will be, and we'll talk about it on future episodes. Thanks again, Scott, for the feedback. Michael writes in, hi, I'm from Indiana. I used to listen to the Police and Fire on my scanner, which is a Uniden Bearcat BCD996T. For 5 or 6 years, I took it to an expert who programmed the local channels for me, and it worked fine. About 2 or 3 years ago, it went blank. I get nothing. I asked a local police officer what happened, and he tells me they changed all the radio traffic so the scanners do not work any longer. Is this true? If not, can my scanner still listen, or is it obsolete? I am totally confused and cannot find anyone who will help. Thank you in advance for all the work you do to educate the public. I feel the public should still be able to listen to police and fire traffic since my tax money is being used to support them. A lot of people echo what you have to say. I'm going to take a neutral stance on the podcast, because I don't want to be labeled one way or the other. That's really what it comes down to, all right? So, my local police department is encrypted, right? Does that mean my scanners are useless? No. There's other things out there you can listen to, right? And there's other ways you can still get the information that you want to get. Find another way. I mean, since my police are encrypted, yeah, but my fire department will still go out for rescues. If something would happen on a railroad crossing, our MTA or the railroad would be involved, all right? So, yeah, it stinks that things happen when they go encrypted, but, this seems like it's life. More and more departments are going encrypted. But anyway, getting back to the question, I think the best thing you could do is check out radioreference.com and go to the database, and you'll find in there if anybody has updated any information, or go to the forums in the Indiana forums and see if anybody's posted anything. That's really the best advice I can give you right now. If you want to write back in and let me know exactly what county you're located, and I can dig into this a little bit further and get you information on a future podcast. All right? Thanks again, Michael, and good luck in the future with what's going on with your scanner. Steve writes in, I would like to learn how to program the scanner channels. I have sent mine out to be programmed twice now. Also, they only programmed one county, and I'm in the county edge, and he wants to listen to 2 counties. So he wants to be able to be a little bit more selective on the agencies he listens to. It used to be so easy to program. Steve, I agree. It used to be very easy to program. But, things change. Kind of what I'm hoping to do going forward is when the podcast really picks up, I want to start getting more into YouTube tutorials and go through how to program your scanners. I believe the need is out there. The podcast is just a start. It's just a beginning way that I can get information out there. And it's a lot easier to come out with a podcast than it is to do some video production and get something on YouTube. But again, I am going to have a full video-based tutorial on how to program the scanners and use some software to get you up to date on all the changes. All right, so stay tuned. And again, Steve, thanks for the feedback. Kieran checks in. One question I have is in regards to listening to Hudson County Sheriff's Department in New Jersey. My brother-in-law is a sheriff, and I usually scan the dispatch channels when he's working. The thing is, you can only hear the dispatch but not the car. Sounds familiar, right? We talked kind of about this, guys, on a previous podcast. I believe it was session 3. We talked about repeaters, duplex, and simplex operations. So he continues to write, I gave them a frequency counter, and he took it with him to read the frequency. But that was a week ago, and he hasn't heard back from them yet. He says that's not an encrypted system, but he did say that it went digital in the car, so he's wondering if he might need a DMR upgrade. He's using a Bearcat BCD 536 HP scanner. It's the newer one. So I did a quick look in radio reference. I went to the database, and for Hudson County, New Jersey, it looks like the sheriff's office is using both analog and P25 on their dispatch channel. So you may want to set up, if you haven't done so already, set up your 536 to receive all transmissions, both analog and digital, on the sheriff's dispatch frequency, or set it up both ways. Set it up as analog and digital. But for now, maybe you should take off the analog and digital flag and leave it there and see. Maybe the scanner will go back and forth, and you're not hearing it because the scanner is hard-coded internally as an option for that frequency to only look for analog or only listen to digital. Okay? If you only have it set for analog and a digital transmission comes through, your scanner won't break squelch for that because it doesn't match the program, the programming of that selected channel. All right? I hope that helps. Andrew checks in. He writes, I've been an EMT for 11 years. I was also a firefighter for 3. Been scanning for 12 years. He has a BCD 536 HP, a BC 350A, a BC 350C, and 2 BC 355Ns, and other miscellaneous gear. What he would like to know about is multiple speaker setups for scanners so you can hear them through the entire house. Using multiple speakers, amp splitters. He also wants to know what P25 is all about, and how to set up antennas, gain, amps, and cable. Andrew, all great topics. And I'm happy to say that we will be talking about everything you've asked for on future sessions of Scanner School. I have a buddy of mine that has a splitter set up in his house so he can have the scanners in the basement and hear what's going on out in the garage. So that's a pretty involved topic. We'll get into that on a future session of Scanner School. Just want to let you know I do have all those topics in for scheduled future sessions. All right. Again, thanks you for the feedback, and we'll get those answered later on. Garrett checks in again. Garrett, great to hear from you again. I heard the most recent podcast and that you're getting a lot of interest in learning the unit in BCD 436 HP and BCD 536 HP. I own both of those scanners and have an interest in increasing my knowledge and helping you teach people how to use them. Just a thought, I would throw that out. Garrett, that is great feedback, and you've read my mind. Once I get the podcast up and going, what I want to do is I want to create a online course to go through how to use each scanner. All right, so maybe the 436 and the 536 will be wrapped up into one tutorial, but we'll also do sessions on how to use, the BCT 15XT or the 996P2 and the handheld versions of those. I'm still playing in my mind how to lay it out, but it will most likely be a web platform on something like Teachable or something like that. I hate to say it, but it will probably be a paid course. If you're interested in taking something like that, and I'm only going to say it's a paid course because it's going to take a lot of time and resources to get something like this online. And again, I'm going to have to pay a monthly fee to put the material out there. All right. So if that is something that you're interested in, I am planning on doing web-based tutorials, soup to nuts, on how to use the scanners. All right. This will take you from taking it out of the box to being a full-on expert on how the radios work. If this is something you're interested in, please let me know. Hit the feedback or the comment button on the website, and let me know if you would be willing to pay for something like that. Because again, I am planning on putting something together, but it's a couple months down on the schedule. All right. So again, thank you everybody for submitting your feedback and your questions. I look forward to answering more in next week's podcast. So I hope that you found this session of the podcast helpful. I hope that the new format is keeping you a little bit more engaged in what I'm talking about. Please let me know if it's working. Hit the comment section on the website, scannerschool.com. Again, you can grab the bonus content for this session at scannerschool.com/session5. And again, follow us on Facebook. It's at Scanner School. Twitter, we're at scanner_school. Again, you get both of those links. Actually, it's the fastest way to do it. Be to scannerschool.com/Twitter and scannerschool.com/Facebook. Will take you right to both of our social media accounts. For those of you using iTunes, please, huge favor, when you're done listening to this podcast, please rate and leave a comment for us in iTunes. That's basically the number one way that we can publicize that we're out there on iTunes, because the ranking helps. The feedback helps with the ranking in iTunes. All right. And don't forget, you can leave feedback not only using the website, but you can click on the speak pipe icon in the session. And our new voicemail number, again, is 516-308-2885. Again, 516-308-2885. So again, I'm Phil Lichtenberger, W2LIE. Thanks for listening. Next week, we will discuss some radios that you can use to listen to what we talked about in the first 5 episodes of Scanner School. And right after that, we're going to get into something I know a lot of you have been waiting for, trunking. So until then, I want to say 7-3. Thanks for listening. Thanks for your feedback. And thank you for your support on getting the first 5 sessions of Scanner School out there. I'm Phil Lichtenberger, W2LIE, 7-3.
Thanks for listening to the Scanner School podcast. Be sure to visit www.scannerschool.com to access the show notes and bonus content.